Welcome to the deep dive. Today, we're tackling something pretty mind-blowing.
Oh, yeah?
How large language models, those AI systems that can generate text like nobody's business,
Right.
are getting even smarter.
Okay.
We're talking about multi-step reasoning, the kind of thinking that lets them solve these complex problems that need, well, multiple steps to crack.
It's like teaching an AI to solve a puzzle, not just guess the next piece.
Exactly. And we're going deep into a research paper called Offline Reinforcement Learning for LLM Multi-Step Reasoning.
Okay.
Think of it like a cheat sheet for making these LLMs better thinkers
Yeah.
without needing tons of new data or us humans constantly hovering over them.
It's about efficiency and
Yeah.
letting these models learn more independently.
So to kick things off, can you give us a sense of how LLMs are being used for this multi-step reasoning in the first place?
Sure.
What kind of real-world problems are we talking about?
So imagine an LLM trying to solve a tricky math problem, something that takes more than just plugging numbers into a formula.
Right.
That's what they're doing with data sets like GSMAK and math, full of these brain-tickling problems.
Yeah.
And it's not just about spitting out an answer.
Right.
It's about the steps the LLM takes to get there.
So it's like showing their work, proving they understand the concept, not just memorizing a solution.
Exactly. And another cool example is embodied agent control.
Okay.
Think of a virtual robot in a simulated world,
Uh-huh.
like the ALF world dataset.
Okay.
The LLM is the brain behind this robot,
Okay.
understanding instructions, planning actions, and navigating the space.
So it's like a video game character.
Yes.
Powered by an LLM,
Precisely.
making decisions on the fly.
And that takes serious multi-step reasoning,
Yeah.
because each action leads to a new situation
Yeah.
requiring a new decision.
Okay, so we have LLMs solving math problems and controlling robots.
Yes.
Now, how do we train them to do this? I'm guessing reinforcement learning, or RL, comes into play here.
You're absolutely right. RL is a powerful tool,
Yeah.
but traditional methods like PPO can be pretty demanding.
Mm-hmm.
They're like a student who needs constant feedback
Yeah.
and new exercises to learn.
Okay.
It's a lot of data,
Right.
a lot of computation,
Yeah.
and not always practical.
So it's like teaching someone to ride a bike by constantly holding onto the seat.
Yeah,
They might stay upright, but they're not really learning to balance on their own.
that's a great analogy.
Thanks.
And that's where offline RL steps in.
Okay.
It's like giving that student a bunch of videos of people riding bikes
Mm-hmm.
and letting them figure it out
Got it.
by observing and analyzing.
So learning from existing data, being more resourceful, and I'm guessing that's where DPO,
Yeah.
direct preference optimization, comes in.
Right.
Okay.
DPO is a good example of offline RL,
Mm-hmm.
but it turns out even DPO has its limitations
Okay.
when it comes to multi-step reasoning.
Yeah.
It often doesn't outperform simpler methods, like supervised fine-tuning,
Interesting.
especially for these more complex tasks.
So DPO is like watching those bike riding videos, but not quite grasping the nuances of balance and coordination.
Yes.
Okay.
And that brings us to the star of the show,
Okay.
OREO,
OREO.
offline reasoning optimization.
Okay, now we're talking.
It's specifically designed to boost multi-step reasoning in LLMs.
Okay, OREO, what makes it so special?
One key difference is that OREO learns both a policy model,
Okay.
which tells the LLM what to do,
Mm-hmm.
and a value function,
Okay.
which predicts future rewards.
Got it.
It's like having a coach who not only demonstrates the moves, but also explains why certain moves are better than others.
So it's like having a built-in strategy guide,
Exactly.
helping the LLM understand the why behind the what.
Exactly. And it uses something called the Soft-Bellman equation,
Okay.
which helps it learn from unpaired data.
Mm-hmm.
It doesn't need perfectly matched examples to learn from.
Mm-hmm.
It can extract knowledge from a wider variety of sources.
So it's a more adaptable learner, not as picky about its study material.
Right.
And how does this tie into those rewards you mentioned?
Well, in multi-step reasoning, a few key decisions can make or break the whole process.
Right.
OREO is much better at figuring out which steps deserve the most credit or blame,
Okay.
adjusting its learning accordingly.
So it's not just rewarding the final outcome,
Right.
but understanding the importance of each step along the way.
Exactly.
Like giving credit to the midfielder who set up the perfect pass for the winning goal.
Precisely.
Okay.
And this is crucial
Yeah.
because it prevents the LLM from being misled by short-term gains or being discouraged by early missteps.
Now, the paper mentions different OREO variants.
Yes.
Token level, step level, and response level.
Right.
Can you break down what these mean?
Think of it like different levels of zoom on the LLM's thought process.
Okay.
Token level OREO looks at each individual word or symbol as an action.
Okay.
Step level looks at chunks of reasoning, like solving a part of the math problem.
Got
And response level sees the entire solution as one big action.
So it's like analyzing a play in a football game.
Yes.
You can focus on each individual player's movements, or break it down by formations, or see the entire play develop as a whole.
That's a great way to put it.
Thanks.
And the research explores how these different levels affect OREO's performance, which we can dive into later.
Okay.
But there's one more cool thing about OREO that I want to mention.
Okay.
Iterative learning.
Okay, iterative OREO, lay it on me. What's that all about?
Imagine letting the LLM loose to use what it's learned, gather new data, and then use that data to refine its training.
Okay.
It's like a cycle of practice,
Yeah.
feedback, and improvement.
So it's not just learning once and calling it a day, it's continuously refining its skills.
Exactly.
Kind of like how athletes review game footage to identify areas for improvement.
Exactly. And this iterative approach leads to ongoing gains in performance, unlike some other methods that hit a ceiling after a while.
Interesting.
But the surprises don't end there. You see that value function OREO learns. It's not just useful during training, it becomes a secret weapon
Ooh.
when the LLM is actually trying to solve a problem.
Okay, I'm intrigued. Tell me more about the secret weapon. How does it work?
Think of it like a navigation system guiding the LLM towards the best solution.
Okay.
For example, in math problems,
Yeah.
they use the value function to explore different reasoning paths and pick the most promising ones.
So it's like having a GPS for problem solving,
Yes.
helping the LLM avoid dead ends and find the most efficient route to the answer.
And in embodied agent tasks, where the LLM is controlling that virtual robot,
Right.
the value function helps it choose the best action from a set of possibilities instead of just picking randomly.
So it's making more strategic decisions, considering the potential outcomes of each action, not just blindly stumbling through the virtual world.
Precisely. It's all about making the LLM a more intelligent and efficient problem solver.
Okay, I'm officially impressed, but now for the moment of truth. How well does OREO actually perform? Does it live up to all the hype?
The results are pretty remarkable. OREO consistently outperformed those other baselines we talked about, like rejection sampling and DPO.
Across the board, different tasks, different models.
Yep, across the board.
Wow.
They tested it on GSMA-K and math for math reasoning and ALF World for those embodied agent tasks.
Okay.
And the results hold true even when they scale up the model size.
So it's not just a fluke, it's a robust method that scales well.
Right.
Any specific results that jumped out at you?
What really struck me was the improvement they saw in those embodied agent tasks, especially in new environments that the LLM had never seen before.
So it's not just memorizing solutions, it's actually learning how to reason
Exactly.
and apply that knowledge to new situations.
It's a sign that OREO is fostering genuine learning and generalization, not just rote memorization.
Right.
And this is particularly important if we want LLMs to be truly useful in the real world, where they'll constantly encounter novel problems and scenarios.
This is starting to paint a very exciting picture for the future of LLMs.
It is.
But before we get ahead of ourselves, are there any limitations to OREO that we should be aware of?
Of course, no method is perfect.
Right.
One thing to keep in mind is that this research mainly focused on math problems and those embodied agent tasks.
Okay.
We need to see how OREO performs on a wider range of tasks
Right.
to truly understand its potential.
So more research is needed to see if it's a universal problem solver or more specialized.
Right.
Any other limitations that stood out?
And most of their experiments use relatively small models,
Okay.
at least compared to the behemoths we see today.
Yeah.
Scaling OREO up to work with those massive models is the next challenge.
So there's still work to be done to make it truly practical for those cutting-edge LLMs.
Yes.
But even with these limitations, it sounds like OREO is a significant step forward
It is.
in the world of LLM reasoning.
Absolutely. And the research doesn't just stop at showcasing OREO's capabilities. It ends with a thought-provoking observation about the limitations of relying solely on the policy model as an implicit value function.
Interesting.
It suggests further exploration into the differences between implicit and explicit value functions, which is a fascinating topic in itself.
Okay, that sounds like we're about to delve even deeper into the inner workings of LLM reasoning. But before we do, let's take a moment to unpack what they mean by implicit versus explicit value functions.
Sure.
Why is this distinction so important?
What's fascinating here is that some methods treat the LLM's actions as a reflection of its understanding of good and bad outcomes.
Okay.
It's like saying the model's choices implicitly reveal what it values.
So it's judging its own moves.
Exactly.
Kind of like a chess player analyzing their strategy after a match.
Exactly. But OREO takes a different approach
Okay.
by explicitly training a separate value function.
Got it.
It's like having an impartial judge score the game,
Okay.
providing a more objective assessment.
Okay, I see the difference. But why does having this separate explicit value function matter so much?
Right.
What advantages does it offer?
Well, the research suggests that this distinction might be crucial for really pushing the boundaries of LLM reasoning.
Okay.
They even include some case studies to illustrate this point.
Ooh, case study. I love a good example.
Right.
Can you walk us through one?
Sure. Imagine an LLM tackling a math problem like,
Yeah.
Betty has $50. She earned $30 more. How much does she have now?
Okay.
The LLM needs to generate a series of reasoning steps to arrive at the answer.
Okay. Seems pretty straightforward so far.
Now, let's say the LLM makes a little slip up in one of those steps.
Okay.
Instead of adding $30 to $50,
Yeah.
it accidentally subtracts it.
A classic math blunder. We've
Right.
all been there.
Exactly.
Yeah.
Now, with an explicit value function,
Mm.
like the one OREO trains,
Yeah.
this mistake would be flagged right away.
Got it.
The value function would see that this step leads to a less desirable outcome, a lower reward,
Right.
and signal that something isn't quite right.
Makes sense. But what about that implicit value function? The one based solely on the LLM's actions?
Right.
Would it catch that error?
That's where it gets interesting.
Okay.
The research suggests that the implicit value function might not be as sensitive to these types of errors.
Interesting.
It might still register that subtracting instead of adding leads to a slightly lower reward,
Okay.
but the signal would be much weaker.
So it's like the implicit value function is a bit more lenient, not quite grasping the gravity of the mistake,
Yeah.
while the explicit value function is like a strict teacher catching those errors early on
Right.
and guiding the LLM towards the right path.
That's a great analogy.
Thanks.
And this has some important implications.
Yeah.
Relying solely on the LLM to judge its own actions might not be enough,
Okay.
especially for those complex tasks where even small errors can snowball into bigger problems.
So it's about having that external feedback mechanism
Yeah.
to ensure the LLM is on the right track. And this ties back to what we discussed earlier about test tying search, right?
Right.
How the value function can help the LLM make smarter choices when it's actually trying to solve a problem.
Precisely. And it turns out that using the explicit value function for this search process yields significantly better results than relying on the implicit one.
So it's not just about training, it's about applying that learned knowledge effectively when it matters most.
Yes.
It's like having a good coach who not only teaches you the plays, but
Mm.
also helps you make strategic decisions during the game.
That's a great way to put it. The explicit value function really shines when the LLM needs to make choices,
Yeah.
whether it's navigating different reasoning paths or selecting the best action in a complex environment.
This whole implicit versus explicit value function debate is really eye-opening.
It is.
It's like we're getting a glimpse into how these LLMs actually think
Yeah.
and how we can fine-tune their decision-making processes. It begs the question, what if we could engineer even better value functions?
Yeah.
Ones that are even more attuned to the nuances of multi-step reasoning.
That's a fantastic question. And it's something that researchers are actively exploring.
Okay.
Imagine value functions that can capture not just the correctness of a solution, but also its elegance,
Yeah.
efficiency, and even its creativity.
That's mind-blowing. We're talking about moving beyond just finding a solution to finding the best solution,
Yes.
one that meets multiple criteria. It's
Right.
like going from a basic calculator to a sophisticated problem-solving tool.
Exactly. And this research on OREO is a big step in that direction.
Okay.
It's not just about a new method. It's about a new way of thinking about how to imbue LLMs with true intelligence,
Yeah.
with the ability to reason, plan, and make strategic decisions like humans do.
So while OREO might have its limitations, it's clearly pushing the boundaries of what's possible in the field of LLM reasoning.
Absolutely. It's a beacon illuminating the path towards more intelligent and capable LLMs, capable of tackling increasingly complex challenges.
And as we know, the more complex the challenge, the more rewarding the deep dive.
Indeed.
So for those of you eager to explore the nitty-gritty details of OREO's performance, join us for the final part of our deep dive.
Welcome back to the Deep Dive. We're wrapping up our exploration of OREO And I have to say, this has been one of our most thought-provoking deep dives yet.
It's truly fascinating to see how these LLMs are evolving from simple text generators to sophisticated reasoning machines.
Before we send our listeners off to ponder the future of LLMs,
Right.
let's tie up any loose ends.
Sure.
We touched on those different variants of OREO, token level, step level, and response level.
Mm-hmm.
Did the research paper have a clear winner in terms of performance?
They did. It turned out that the most straightforward approach, token level OREO, actually performed the best overall.
Interesting. I would have thought treating entire reasoning steps as actions, like in step level OREO, would have been more effective.
It's a logical assumption, but remember the value function, that internal judge we talked about,
Right.
might not be perfectly accurate at each individual step. Okay.
Treating those slightly inaccurate estimates as separate rewards could actually introduce some noise into the learning process.
So too much granularity can backfire. It's like trying to micromanage every tiny detail instead of focusing on the bigger picture.
Exactly. Sometimes a little less precision can lead to more robust learning. And as for response level OREO, it didn't fare as well. Remember how we talked about credit assignment, pinpointing those key steps that really make a difference in the reasoning process?
Yes, like giving credit to the chef who created the recipe, not just the server who brought out the dish.
Well, response level OREO, similar to DPO, struggles with that. It treats the entire response as one big action,
Right.
making it hard to isolate those crucial steps that deserve the most attention.
So token level Oreo strikes that sweet spot, providing enough detail to learn effectively without getting lost in the weeds.
Precisely. And this simplicity is a big plus when it comes to actually implementing OREO. No need to overthink things. Just focus on the individual building blocks of the reasoning process.
Elegant and effective, just how we like it. Okay, one last thing before we wrap up. Let's circle back to that iterative learning concept. How much improvement did they see with each cycle of Oreo?
The results were quite compelling with each iteration, where they let the LLM use its updated knowledge to gather new data and then retrained it.
Hmm.
They saw steady gains in accuracy.
And this held true for both math reasoning and those embodied agent tasks.
Yes,
Yeah.
across the board. It really highlights the power of continuous learning, of giving the LLM a chance to practice, learn from its experiences, and refine its strategies.
It's like the difference between studying for a test once and calling it a day
Right.
versus constantly reviewing and reinforcing what you've learned.
A perfect analogy. And what's even more interesting is that some of those other methods, like rejection sampling, showed signs of plateauing.
Yeah.
Their performance peaked after a certain point, while Oreo just kept getting better with each iteration.
So it's not just about squeezing every last drop of knowledge from the existing data. It's about using that knowledge to explore new possibilities and discover even better solutions.
Exactly. It suggests that Oreo is enabling a more dynamic form of learning, one that goes beyond simply memorizing patterns and starts to resemble the kind of creative problem solving we see in humans.
This is all incredibly exciting, but it also raises some big questions. Can we scale Oreo up to work with those massive multi-billion parameter LLMs that are all the rage these days?
That's the million-dollar question. And it's something that researchers are actively working on. It might require some clever algorithmic tweaks or even new hardware to handle the computational demands of training those behemoths.
And how will Oreo perform on a wider range of tasks? Can it be a general purpose reasoning engine, or is it more specialized?
These are all questions that future research will need to address. But even with these unknowns, it's clear that Oreo is a significant leap forward in the quest to build truly intelligent LLMs.
It's like we've opened a door to a whole new world of possibilities, a world where LLMs can reason, plan, and solve problems with a level of sophistication we've never seen before.
It's a thrilling time to be in this field, and I, for one, can't wait to see what the future holds.
Me too. It seems like every day brings new breakthroughs and new challenges, but as we've learned today, even the most complex problems can be solved one step at a time. And with that, we'll wrap up another deep dive into the world of AI. Thanks for joining us.